Hey, welcome! Today, we're going to talk about something huge, a massive shift that's completely changing our digital world. But the thing is, it's happening kind of behind the scenes. We're going from building these rigid digital skyscrapers to creating flexible, intelligent, smart cities. Let's dive in. So, have you ever wondered about this? Your favorite streaming app seems to get new features and updates almost every single week, right? But the software you have to use at work? Well, it feels like it's stuck in the Stone Age. The reason for this isn't just about new features, it's about the very foundation, the architecture of how these things are built.
All right, so let's rewind a bit and talk about the old way of doing things. For decades, we basically built software the same way we built skyscrapers. These massive, single structures, monoliths, that were designed to be super strong, super stable, but also super stuck.
And wow, this image really says it all, doesn't it? This is what we call monolithic architecture. Everything, and I mean everything, is tangled together in one giant code base. It was all tied to physical servers, which meant just getting more space could take weeks. And because it was all so interconnected, making one tiny change could literally bring the whole building crashing down.
And you can just feel the pain points here. Need more power for a big sales event? Too bad, scaling was slow and crazy expensive. Want to roll out a new feature? That was a terrifying all-hands-on-deck manual process. And trying to move to a new system? An absolute nightmare. Because every single piece was so tightly connected, it was like trying to renovate one floor of a skyscraper without the entire building shaking.
But what if, instead of one giant, clunky skyscraper, we built an entire city? You know, a whole collection of smaller, specialized buildings that you could build, update, or even tear down and replace, all on their own. Well, that right there, that's the big idea behind the modern, cloud-native way of thinking.
Okay, this slide is the perfect before and after. On the left, you've got that rigid monolith stuck on its physical hardware. Now look to the right. That is a dynamic, living, digital city. It's a whole network of independent services, all running in the cloud, with systems that can grow automatically and push out updates all the time. I mean, the difference is just night and day.
So, how do we actually build this modern city? What are the tools? As you can see here, it really boils down to a few key ideas: microservices, containers, and this process we call DevOps, or CI/CD. And these are not just fancy buzzwords. They are the actual blueprints for building software that's fast and flexible. Let's look at each one. First up, microservices. Instead of one giant skyscraper, we have a bunch of specialized buildings. Think about an online store. The part that handles your user profile, that's one service. The product catalog, that's another. The shopping cart, a third service. Each one can be built and updated by its own little team, and it won't break anything else. That means way faster updates.
Okay, next up, containers. So how do you move all these different services around easily? Well, you put them in containers. The best way to think about this is like standardized shipping containers in the real world. A developer packs their little service, with all its code, all its needs, into one of these containers, and it's guaranteed to run the exact same way everywhere. This basically kills that age-old developer excuse, well, it worked on my machine.
And finally, DevOps and CI/CD. This is like the city's super efficient automated construction and road crew. It's a way of working where developers and the operations folks are on the same team, using these automated pipelines to constantly build, test, and release new stuff. It's how they can roll out tiny improvements all the time, reliably, without ever having to shut down the streets. Okay, so let's make this super concrete with a perfect example. Your favorite streaming service. That amazing recommendation engine, it's actually a whole bunch of different microservices working together. Each one runs in a container, so when a new hit show drops and everyone rushes to watch, they can scale up instantly. And when they cook up a new, smarter algorithm, they use those CI/CD pipelines to test it and roll it out without you ever seeing so much as a loading screen. That's the magic right there.
But you can't just throw up a bunch of buildings and call it a city, right? It'd be chaos. A thriving city needs rules, zoning laws. And the same is true for our digital city. There are these core principles, these laws, that make sure everything runs smoothly, securely, and efficiently.
So here are 5 of the big ones. It starts with automating absolutely everything you can. It means building what we call stateless components, and we'll get to that in a sec. It's about using the pre-built services from cloud providers instead of reinventing the wheel. You need layers and layers of security. And finally, you have to accept that the city is never finished. You're always architecting. I want to zoom in on number 2 for a second because it's so important.
Okay, let's break this down. In the old stateful world on the left, your online shopping cart information was basically stuck to the one specific server you were talking to.
If that server had a bad day and crashed, poof, your whole cart was gone. But in the new, stateless world, your cart data is stored in a central place, like a shared database. Any server can grab it and help you out. So if one goes down, another one just steps in seamlessly, and your cart is totally safe. This is absolutely crucial for being reliable and for scaling up.
Now take it a step further. Imagine you're not just the mayor of one digital city, but you're managing multiple cities spread out across different cloud continents, like having operations in Amazon's cloud and Google's and Microsoft's all at the same time. This is the reality for a lot of big companies now.
And this slide kind of breaks down the two main strategies. On the left, you've got multi-cloud. That's using a bunch of different public clouds for what they're best at, maybe Google for AI, AWS for storage. On the right, you see hybrid cloud. That's when you mix a public cloud with your own private, super secure data center. Banks love this, by the way. They keep the really sensitive stuff locked down in-house.
But, being the mayor of multiple cities is not easy. It comes with a whole new set of headaches. There's this wild idea called data gravity. We'll get to that. You've also got network lag, completely different tool sets in each cloud, and just a massive challenge trying to keep security and compliance rules consistent everywhere.
And this quote right here really puts that data gravity problem into perspective. Data literally has mass. The bigger your data set gets, the harder, slower, and way more expensive it is to move around. It's why big projects tend to gravitate towards one cloud provider. Moving that much data back and forth is a logistical nightmare.
So, where is all of this going? Well, the future of our digital cities is getting more autonomous, way more intelligent, and honestly, it's forcing us to ask some really big, really important ethical questions.
We're stepping into this new phase called agentic AI. These are basically AI agents that can do complex tasks for us. So imagine an AI that spots a failing data pipeline, diagnoses the problem as a formatting error, and just fixes it itself. Or an agent that sees new data, automatically classifies it as sensitive, and applies all the right security rules. Basically, our digital cities are starting to think for themselves.
But, and this is a huge but, with that kind of power comes enormous responsibility. This is a real stark example of what happens when that goes wrong. An AI tool for hiring trained on a company's past hiring data just learns the biases from that data and starts discriminating against women or black applicants. This isn't just about code anymore. The architecture we design has real human consequences.
It all comes down to this simple, powerful truth. Data quality isn't just a technical issue. It's a deeply ethical one. If the data we're feeding our intelligent systems is garbage, if it reflects historical inequality and bias, then the decisions that AI makes will be biased and harmful. The entire system, from the ground up, has to be built with fairness in mind.
And that leaves us with this final and I think most critical question. We are building these incredible self-governing digital cities that are going to power our future. But as they learn to think for themselves, the single biggest architectural challenge we face isn't technical. It's making sure we build them on a foundation of fairness and ethics so that they work for everyone.